Welcome to this fifth video in our series on introducing you to 3D Studio Max. We're going to move right on here. I'm going to quickly make a cylinder and we'll go full screen. And the first thing that I want to talk about here in this fifth video is our reference coordinate system, which we see right here. We have a few options to pick from. And these are important because this is going to show us how we are going to have access to and can manipulate these objects here in 3D space. So with it set to view, and also know that each one of our move, rotate, and scale can have different reference coordinate systems set up. So we can have this one on screen and we can have this one on world. And as you can see, each one will always hold that setting. So I'm going to go ahead and just set them all back to view for a second. And we're going to talk about view. And this is not going to be an in-depth explanation of all of them. Again, I will refer you to the help file for that. I'm just going to show you the basic ones, the ones that you need to be familiar with to begin with. So as we can see here, we're on view with the move, and we can see that we have our gizmo, and down here in the corner you will see that we have a duplicate image of our gizmo down here in the corner. And this will always be here to always give you a quick frame of reference down here in the corner of how you are looking at your view, which way is Z pointing. It's always going to give you a reference, and notice even without anything selected we can always see which way we are actually positioning ourselves as it relates to 3D space. So, and you'll notice as I'm rotating my view, my gizmo is changing in relationship to it as well. So I'm going to go ahead and switch to my rotate tool, and we can see the same thing here occurs with our gizmo. And I'm going to go ahead and just go back to view for a second. And I know that we've talked about it and touched base on it briefly, but with this gizmo that we have here, this is our way of accessing our objects, and we can move obviously on the X, the Y, or the Z, or we can move it on the Y and the Z, the X and the Z, or the X and the Y, but we can't move it on 3 dimensions at once. Maybe sometime in the future they'll figure out a way of doing that one, but as it stands, that's not a possibility. If I go to rotate tool, we see we have the same abilities. We can rotate on these axes. If we don't pick on one explicit one, then we're going to rotate around on all 3. So you can notice down here at the bottom that I'm rotating on all 3 axes at one time. So we can do it just on one. We can come out here and we can basically rotate around how we're looking at this object. You see that's what this is doing. Or we can go explicitly on the axes, or we can just click anywhere and rotate it on all 3. Same thing with our scale. We can scale in 1 axis, we can scale in 2, or we can scale uniformly in 3. And we see we've got the ability to go non-uniform scale here. Same this one. I just prefer leave it on the normal scale tool because, as you can see, it's not too hard to ununiformly scale this object depending on which way you put the mouse. So we'll keep things as simple as possible. So I'm going to go back to my rotate tool now, and one of the things that I want you to notice here is as I'm rotating this object, notice that my gizmo is not changing. Because we are still set to our view reference coordinate system, and that is always going to be exactly what we're seeing no matter how we rotate around, we're always going to see exactly where the z-axis is. It's always going to be the same place. Same with the y and the x. Now, if we switch to view, from view to local, notice that the gizmo changed. It's now orientated with the object, and as we rotate the object, the gizmo is going to rotate with it, which is very handy because I can always see at any time during the rotation, I can get a visual image of which way this object is going to rotate if I take it on this axis, if I take it on the x-axis, or if I take it on the z. I always have a very visual way of picturing any future transformations. So I'm going to go back to move real quick, and we see that it's still on view, so I'm going to switch it to local, and notice the gizmo changed again. It's now orientated with the local changes of this particular object, and now Z is pointing up the object, or towards the object's top, and then obviously X and Y have orientated themselves as well. So now what this would be good for, obviously, if let's say we had a cannon and we wanted to animate a cannonball being shot out of it, or if we wanted to animate a bullet, then with just view we'd have to move it on two axes, and you know, I mean, obviously it won't be too hard to animate this going very straight, but if we had it set to local, we can just pull it on one axis and be dead sure that that's going on a straight line. So same thing with scale. It's going to now follow the direction of the object, so it's any local changes that are to just this particular object. Notice if I have a box, I'm on local. If I switch to view, notice it doesn't change. View or local, nothing has changed because there have been no adjustments, no manipulations to this object. This object is exactly the way it was created. Everything is lined up by default. But as soon as we make an adjustment, our gizmo is going to be reflected when we have it set to local. So definitely wanted to make sure that we covered that, and that you are aware of it and familiar with it, because it is very useful, very important to understand, especially when it comes to animating. Okay, so we have talked about a lot of our basic things. Obviously we have a lot of things still in here to talk about. Just keep in mind that a lot of these are very simple. You want to make a door, there's a pivot door, and we can go to over here and open the door. So like I said, that's why I'm not really wanting to spend an incredible amount of time with these, because a lot of these things are pretty self-explanatory and easy to figure out. So what we're going to talk about now, we're going to move from we've done a geometry pretty well, and we've done our splines. We're going to go ahead and talk about lights, which is another important aspect to any three-dimensional scene. So I'm going to make a quick little setup here, and we'll make a sphere, and we'll do a cube. Okay, and so we're going to talk about lights. Okay, the first thing that I want to introduce you to when it comes to lights, or talk about, is one of the best things you can do would be to study lights, get some books on lighting. There are plenty books on the topic. You can even go into Wikipedia and pull up some basic stuff, and I've got things like that on my website as well for lighting. But what we're going to talk about first, we're going to talk about our target spots and our free spots, which is kind of run down the list here. Target spot is going to be a spotlight, obviously, and how we create them is the first place that we left click is going to be the position of the actual light itself, and then as we click and drag, we see that we are going to be creating the place where the light is pointing. So I'll just go ahead and click, let go of the mouse there, and now I will go to my move tool, and we see we are automatically selected on our light, and since I am set to local, we can see that I can very easily pull this light out, pull it back in, whatever. Okay, and we have some important things here to discuss. One of the things that we can do is we can actually see what the world looks like from our camera, or I'm sorry, from our light source. If we go and hold down the V key, I'm sorry, not the V key, that is, let's see, views and spotlight 1. Now we are looking directly out of our spotlight, and now all of our tools down here are actually going to be tools to manipulate the way our spotlight is working in the scene. So once we're happy with the way our spotlight is set up here, then we can hit P to go back to perspective, and now we are back the way we were. And we can move this back around and everything's good to go. Okay, so with lights, a big part of what lights bring to your 3D world is every realistic area, or let's just say any part of the real world, is going to be affected by light. And the best way that we can actually see how well you are representing real life as you begin modeling and you move into your career is actually the lighting. How are you presenting the lighting? And a lot of this is determined in the scene through our rendering. So I'm going to go ahead and move my toolbar all the way over to the left so we see our little teapots here. And what this is going to do, this is actually giving us access to our renderer. So I'm going to go ahead and hit this teapot, which is the quick render. Just click it, and we see this is what our scene that we have created here actually looks like. This is the way that this is our little scene here in all of its glory, as best as we have told Max to create it. And obviously it's not that great. We haven't done much here, obviously. But what I'm going to do is I'm going to take a look at our light, and we're going to break down some of the concepts and things that we need to know about this light. So first off, we'll go to the modifiers, our modified panel, and we see that the first thing we can do here is we can change the type of light that it is. We're going to leave it on spot for now, and if we want to turn it off, we can turn it off like so, tell it to be targeted or not targeted. And we can tell it to have shadows or not. And as we can see, if we hit render, we have no shadows in our scene. So I'm going to go ahead and hit shadows on, and now we have shadows, which makes sense if we're going to have a light. All light casts shadows in the real world, but obviously the fact that we can tell this light not to means that all lights in our 3D world don't have to cast shadows. So just keep that in mind. But for the most part, yes, all of our lights should be casting shadows. They do in the real world. And then we have a little list here of different kinds of shadows that we can cast. And for now, we're going to go ahead and leave it on shadow map. That is the simplest. Notice we have an exclude here, so I'm going to go ahead and open this up. And let's say I wanted to exclude the sphere from both illumination and shadow casting. So I'll select the sphere, hit the double arrows to add it to the list, hit OK. Now we don't see the difference here, but when we render, notice this object is no longer getting affected by our light source. Now, why would you want to do that, you might ask? Again, it's more important that you are aware that that can be done. The first example that would come to my mind would be, let's say that this is a lantern and our light is inside the lantern. Well, we wouldn't necessarily want our light to be affecting the lantern itself, because if it's inside of it, like the sphere, if the light is inside of it, well, obviously it's not going to be casting any light because it's locked inside. So that would be a situation where you would say ignore this particular object and cast your light outwards. But for now, just don't worry about it. Just know, like I said, that it is an option. So we're going to move on down to our intensity color. Obviously this is going to be the brightness of our light, and obviously this is going to be the color of our light, which is going to change our scene dramatically. And if you have been on my forum at all, you'll see that a little tip that I recommend when it comes to lighting is to set your decay to inverse. And now we see the start decay is set to 40. And what this means is that obviously 40 is that parameter right there. And what that means is that at this point from here on, the light is full strength, and it is at this point at which it starts to decay into nothingness. So we'll leave it on 40, and we'll leave the light exactly where it is, and we'll render again and see what that did to our scene. And I'm not sure how well you can see this on the video, but we can see that it's gotten a lot darker. Now I can crank this up, and we can start to get things, brighter again. But the important thing to know is that this is actually setting our light, the actual light source, to actually be resembling and acting like a real light does. Real lights start, intense at its source, and they're going to diminish as they move on, as they move away from the light source. So if we set this to none and put this down, we see that this guy is just going on, and we see that it's diminishing a little bit, but nothing like it was before when it's set to inverse. And things to keep in mind with that is when a lot of people are starting to light their scenes. Let's say we'll leave the multiplier there, and I'm going to go ahead and copy this object, this light source, over here, and maybe I'll make another one over here, and I'll do one more over here. Okay, so that's 4 lights, and you know what, let's do this another way so I don't have to make a lot of changes. I'm going to make this light an instance, and we'll move this one to be another instance, and we'll do one more, another instance. Okay, so we have 4 lights completely lighting our scene from all angles. And let's say we zoom in here just to our scene, and we hit render. Everything's pretty bright. Just going to go ahead and switch it to inverse. Okay, so everything has gotten darker, and what this using this, what this is going to allow us to do is it's going to allow us to start to treat our lights very gracefully and really kind of build our lighting up. So this is a good time to talk about another parameter. I'm going to go ahead and render this again, and I'm going to increase this a little bit so we can maybe see on the video. Okay, we can see that our spotlights are doing exactly that. We have these very hard spots that are hitting our scene from all sides. Okay, I want to pick on any of our lights here, and we're going to go down to the next rollout, which is spotlight parameters. And what we see here is a hotspot beam and a fall off field. And I'm going to adjust the fall off field first, and we see obviously that is the outer one. And just kind of like the same way the decay is, this is where the light starts to decay into nothingness. It's the same thing that these fall off fields and hotspots are doing. The hotspot is showing you where the light is going to be strongest, and then it's going to diminish outwards. So just by making these adjustments, I'm going to render again. So we see everything is really kind of balanced out a little bit more. We don't have those hard edges, and I'm going to bring these back in just so we can see again the difference here. So exactly like it says, it's a spotlight, which is what we're seeing. We're really kind of getting that appearance like, you know, somebody's putting a spotlight on these guys. And if we just increase our fall off field, I like to do it at least double whatever the hot spot is, at least double for a pretty decent fall off. So as we see, it's really nice and soft, and which is, you know, showing us that our little scene here is being pretty well illuminated and, you know, pretty decently realistic lighting. Obviously you can continue to increase this and we will see that light falling off even more. I'm going to go ahead and use my scale here, and I'm going to scale this guy up all the way. And I'm going to right click. I have my plane selected, obviously. I'm going to right click and I'm going to go freeze selection. So now I don't have to worry about picking on the ground anymore. It's not going to affect my render. It's still there. Everything's still working for us. I just don't have to worry about picking on that object anymore. Okay, so we've talked about the hotspot beams, the fall off fields, and you know, we'll set this back to 1 and we'll take a look at this again, and we see how everything's starting to get kind of blown out because we're at 1 and we're not telling our lights to use any kind of decay. And just so we can see, so you can see for yourself what the inverse square is going to do and how that's different. So there's none and inverse. Okay, so things to keep in mind. Again, I like, let's see, you can take it to 3. Okay, so just still notice it's even going to 3. Our lighting just looks a lot better, and we still don't get that blown out effect like we do with them all at 1 and none. Everything's really kind of getting blown out here in the center. So I hope that you guys see my point with that. I like it on 3. That looks pretty good. Okay, so we'll go ahead and skip on down here, and we have the ability to tell this any particular light to only hit the diffuse. Since these are all instances, the only thing they're going to affect is the specularity. So that's what we kind of see here, is it's just showing up like the highlights of the objects. Or we can say just the diffuse and don't hit the specularity at all. Or we can say just light it ambiently. So and obviously if they weren't all instanced, then we can do all this stuff the same. You know, pick and choose which ones we want. We can also have our lights be a projector map. The best way to think about this is if you think about a movie theater, how the light source is actually projected onto a screen, an image. Well, you can actually use this and come in here and you can load up, I'll just, for a quick example here, let's see, I will load up oh, you don't like QuickTime, huh? So we can see here all of what it likes. It only wants an AVI, and I haven't rendered out an AVI in I don't know how long. I don't even know if I've got an AVI on my entire computer. But it could be an AVI, or it could just be an image. I guess I can just do an image. If we go, and then we go into Autodesk, and we'll go into Max, and we'll come down, and let's see which one would we like. I know there's got to be something in here. We'll do a background. We'll do the creek. Okay, so since they're instances, all four of these lights are now going to be projecting this image onto into the world, which is what we see. I'm going to turn this off, so it's off for all objects. And now I'm going to make this one that I'm selected on. I'm going to come over here and press Make Unique. So now these three are still instances, but this guy is special. And I'll turn that on. And we can see that one light is projecting that creek image into the world. So again, just things to think about. Come down here to our shadow parameters. Here we can tell the color to be, of the shadow, whatever we want. We want the color of the shadows to be blue. Well, then we'll do something a little bit more drastic, maybe red. So the shadows on just this one object here, we can see are tinted red, and we can raise this up so now it's very obvious that it's red. Why would you want to do that? You never know. There are so many times in which you think you might not need something, and then you just got to ask yourself, they have it here for a reason. Light effect shadow color, what that'll do is, say based on the actual color that you're using, the intensity and all those things, that it's going to affect the color of the shadows. It's typically a pretty good thing to have turned on. Shadow map parameters, this is going to be one of the last things I talk about, only because you can get some pretty good effects. As we see here, we got all these shadows from our objects being casted, since we've got all these 4 different lights. And I'm going to copy again, just so they're all instances once more. And I want this guy over here. Alright. So again, with this one, what I'm going to do, again, we can see that our shadows, are very hard-edged. And what I'm going to do is just take my sample range and I'm going to increase that to like 30. And we see that those shadows get blurred out. We can say maybe 15. Okay, so we can play around and we can get these different effects depending on what you like and what you want to see in your scene. Let's go ahead and take our bias up, and I'm going to bring the sample range back down just so we can see what this change alone is going to do. And we'll just go ahead and completely reset it. So this is back to where we were. And let's crank the bias up a little bit. So absolutely no shadow. And let's take this down to like 0.2. And it's just getting it hard. What it's doing is falling off from the point of where the shadow would start. How far past the actual point is it going to go? And we'll set this back to 1. And our size being 512, what that is, this is a shadow map, so Max is actually calculating in an image that's going to be drawing the shadow on the ground. And if you raise that, all you're doing is you're telling Max to increase the detail of the shadow. So I'm going to take it down to 64, and we see it's another way we can blur out those shadows. And let's go 128. And let's go to 512, which is about where it was. So it's how dense of a map do you want to have Max draw. Obviously, you start going into this realm, the shadows are going to get a lot finer. We can come in here and really see that they're very sharp. So again, if we take this down to 256, see it's getting fuzzy and blurry. So I recommend leaving it at 512, and if you're going to do anything, you can lower it, which would actually, because Max has to calculate all these things. If you want to blur it, you can lower this, you can raise the sample range. But if you want the shadows to be sharper, then I just recommend that you come up here into the shadows and tell them to be ray trace. As you see, what that's doing is drawing the shadows as perfectly as possible. It's actually casting rays to generate these shadows. Again, if you want a big in-depth explanation on those, then you got the help file waiting on you. But there's a quick rundown of the basics of a light, and obviously each light that you're gonna make, let's say we make an Omni. All these lights have the same issues, the same settings. Everything is here. And what I want to let you be aware of, this Omni light, keep in mind that an Omni light is actually 6 spotlights joined together. So if I make a free spot, we see that it's doesn't have a target. It can be placed and moved around. But if we actually were to hit A for my snaps here, if we were to do something like this, and we'll go over here and then one more. Okay, so that right there is 6 lights up, down, all the different sides. That is essentially what this Omni is 6 lights put together. So just keep that in mind. If you know, a lot of people want to start just using Omnis to light their whole scene. I mean, which is fine, you know, you can use that, but just keep in mind that you don't just have 4 lights in the scene. You've got 4 times 6. That's how many lights you actually have in your scene. That's how many lights you are forcing Max to calculate. So keep it in mind. It's the same thing as resolution with your meshes. You don't want to go past the point at which you need. Okay. The next light I'm going to talk about just real quickly would be if you want to make a sun. If you wanted to simulate a sun, your target direct is going to be your best bet. We can just click and drag this out and use our move tool. And if we go over here, if it's the sun, you definitely want to have ray trace shadows. And we see that our target direct is acting like a spotlight because of this our fall off fields here, hotspot and our fall off. But since this is most typically used as a sunlight, what you would want to do instead of increasing this to hit everything, you just say overshoot, and now it's going to light everything. No matter how far away it is, it's always going to pretend like, or it's always going to have this sunlight hitting it. Okay, so the last thing about lights, and then we're going to leave, I'm going to leave you on this series, is the skylight. I'm just going to click and create this, and I'll just move this up so we can see it. The placement of this light is of no matter. It can be placed anywhere. It can be rotated. It doesn't matter. It doesn't matter how big it is, if it's underground, if it's above ground. None of these things matter when it comes to the skylight. The only thing that matters is that it is in the scene. And what this skylight is good for is, I'm going to turn it off for a second and render. We see how dark our shadows are. With this, just going to go ahead and hit on. We see everything gets lit and our shadows are no longer dark. Well, I'm going to go ahead and crank down the multiplier to like 0.3 and render again. And we see that we're now getting some color. We're seeing the effect of the sun, and we're seeing the shadows, but the shadows are they're no longer black. What we're getting is actually we're getting this bounce lighting effect all around the world, and that's the way light really behaves in the world. And so it's just, you know, something that you want to keep in mind as you are lighting your scenes. If you see, you know, that it's really dark, obviously you could go in and go into the, tell it to be shadow mapped, and you could go in to the shadow parameters and make the density less and change the shadow color. But notice it doesn't have the same thing. Notice the sides here are still really dark, so we have, you know, bright, really dark, and then all of a sudden you know, not so dark shadow, which doesn't look right. So that skylight makes a big difference. And 0.3, 0.4, whatever, still works pretty good and gives really nice lighting. So that's the basics of our lighting, the reference coordinate system, how useful that can be, why it is useful. So we'll go ahead and we'll leave that alone for now. Just wanted you to be aware of it, and, you know, just some basic parameters on how to use and create lights and what they are used for and how to use them. So I will see you next time, and thanks for watching.